All right, so it's the start of semester 2, and for most of us, it's the final push. Right? We're graduating in 5 months.
Why are you looking at me? I'm
Because-
gonna graduate.
I know, that's what I'm saying. We're graduating in 5 months.
I thought you were saying for some of us it's the final push. For others
Well,
it's not.
because there's a couple of juniors in the class, so for them it's not the final push. You know what I mean? They got a whole other year to go yet.
What's the drop out of high school?
All right, so 2 tweaks to second semester. First one, and you guys are phenomenal right now at home. Excuse me. Cameras, I'm expecting that your cameras are on now during live classes. Which, side note, all 3 classes are now live. So Monday, Wednesday, and Thursday are all live classes. I expect your cameras on, unless you have a pre-existing rationale, meaning you told me about it already when we started talking about this last semester. Okay? Or you have it on file somewhere in the counselor or office notes. The big one, though, that I want to talk about now is late work. Okay? Formatives, late work formative, whatever. That's going to stay the same a week after, excuse me, hiccups all of a sudden. A week after the summative is when those start becoming late. That's going to stay the same. What's new this semester is summatives. If you're late on a summative, I'm going to take off 10% per week. Okay? So 10% per week. So if you do it the next day, the day after it's due, you only can, the maximum points you can get is 90% of whatever the maximum is.
So if it's late. then
So if you turn it in 1 minute late,
then
it's a 10% deduction.
And then it's
Basically, there's another week because that's
And then if you turn it in a week and a day late, then it's 20%. Okay? So the rule of that one, don't be late. Get your stuff done on time. Okay? Alright? That's the easiest way to get around that one. Okay? For those of you joining us on the line, I handed out to the peeps in the room a note sheet for tomorrow. Okay? That's the first page. And the homework for this week, which is the second page. For some reason, I forgot to print off next week's homework for it, too, so I'll hand that out to you guys tomorrow, next week's homework, so you have a paper copy of it. All of those, for those of you at home, are online. And you will need a piece of graph paper today, too, because we need 4 graphs today. Okay? So, let's talk about graphing. Today, what we're going to start is we are going to start Unit 6. Unit 6 is all about solving systems of equations. Okay? So the first way that we're going to learn is graphing. Then we'll learn elimination and substitution, which those 3 you've already done before. And then we'll add in a 4th way to solve a system of equations, which is matrices. Okay? So if we're going to be graphing today, we should probably remember the ways to graph a line. Okay? What was that? Oh, straight? Yes, we should graph our line straight, which we'll get to in a minute because we're going to need to be accurate with our graphs, so we're going to need some kind of a straight device to help us. IDs, sides of telephones, rulers are the best, obviously, but not everybody has one. You can take your piece of paper and you can bend it over too, and then that will give you a straight, something that you can use. Edge of a notebook, something along those lines. Okay? So we'll need that later on. So the first way that we know how to graph a line is the old-fashioned y equals mx plus b method. Where in that particular method, what we do is we plot, I should say let's plot, yes, let's not say graph. Let's plot point 0, comma b. That's our y-intercept. So we go up or down b from the origin and we put a dot. And then we use m equals the rise over the run to get more. Okay? So we get 2 or 3 of those, and then we draw our line all the way across the graph, and we're good to go. Okay? You guys have been doing that probably since the 7th grade. Okay? Second way that we know how to graph a line, you can find points on our line by using a t-chart. Okay? We can pick x's or y's, plug them back into the equation, get the other one, plot those points, connect the dots, la 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 la. Okay? Good method, very, very effective. Okay? And the last method is using intercept. The intercept method is you plug in 0 for x to get the y-intercept. 0, comma, some number. And then you plug in 0 for y to get the x intercept. And those 2 points then you connect and you have your line. Okay? So 3 different methods. Obviously, I'm very partial to method number 1 because I feel that that's the best way, the easiest way to graph a line. But by no means do you have to use that particular method. Okay? You can use any of the others. Okay? Love it. So what's going to happen here in 6-1 is when we solve by graphing, we're going to take 2 or more lines and we're going to put them on the same graph. And so if I take 2 or more lines and I put them on the same graph, there are 3 potential outcomes that can happen when that happens, or when we do that. Then the 3 outcomes are, hold on one second, let me get the infinite case up in there so that we can show them all at once. There we go. Oops, and then I forgot I got to do this. Oh, so many things to do. Yeah. So, if I'm graphing 2 or more lines, the options that I have is I can have exactly one solution. So they all cross at one point. I can have no solution, where none of the lines cross or intersect. Well, they're parallel lines, yep. Or we can have infinite solutions, where the lines that we graph all are the exact same line. And truthfully, those are the 3 possible outcomes for this entire unit. Okay? When we're solving a system of equations, we're either going to get exactly one solution, no solution, or infinite solution. Okay? So when we're solving a system, those are the only 3 outcomes that we can get. Yeah? So, let's put it to work. Okay? So we want to graph. So to solve by graphing, there's really two steps. One, you want to graph the two equations on the same graph, and then if they intersect, you want to give the coordinates of that point that they intersect. If they don't intersect, you want to say that there's no solution. And if you have only one line graph, then you want to say that there's infinite solutions. Okay? So let's do example number 1 here. Let's solve this via the graph method. Okay? 3x minus 4y equals 8, and 3x plus 4y equals 16. So let's take one at a time. We'll take the blue line first, since it's on the left. I'm a big proponent of y equals mx plus b, so I'm going to subtract 3x from both sides. By doing so, that gives me negative 4y equals negative 3x plus 8. Then I would have to divide every term by negative 4. And that's going to give me y equals positive 3/4 x minus 2. So to graph that, I'm going to go down 2 from the origin. I'm going to put a dot. That's my y-intercept of this particular line. Then from that, I'm going to go up 3 and right 4. I can do that a couple of different times. Or I could go down 3 and left 4. And I get those lines. Then, this is where something straight is going to come into play. Then, you take your line and you draw it all the way across your graph. The reason that we have to draw it all the way across our graph is because we are going to be putting a second line on this graph. And we don't know where it's going to cross. So if I only drew my line, come on. If I only draw my line like that, not so good. Because if it crosses somewhere on the right half, I wouldn't know. Okay? So we have to draw our line all the way across the graph. At least the first one for sure. Okay? Then we go to the second graph, or the second line. It is in green. So here I'm going to subtract 3x again. That's going to give me 4y equals negative 3x plus 16. Divide everything here by 4. And that's going to give me y equals negative 3/4 x plus 4. Excuse me. So I'm going to go up 4. And that. Then my slope is negative 3/4, so down 3, right 4. Down 3, right 4. Up 3, left 4. Excuse me. Connect those. With a line. And it appears, so now I'm looking for where it crossed or where the two lines intersect. It appears that it intersects right there. Green is crossed with blue. So my solution is the point 1, 2, 3, 4, up 1, so that is the point 4, comma 1. Now, there was rampant cheating going on in first semester. Trust me, I know. Okay? You don't need to cheat on this stuff because you're going to know right away when you're done if you're right or not. Because I'm going to put 4 comma 1 back into both of my equations. 3 times 4 minus 4 times 1. 3 times 4 is 12. 4 times 1 is 4. 12 minus 4 is 8, and that is equal to 8 in the blue equation. 3 times 4 is 12, plus 4 times 1 is 4. That's got to be 16. 12 plus 4 is in fact 16. So it checks out. So you'll know 15 to 20 seconds after you're done with the problem if you got it right or not. No, because then it would cross over my line. Oh, the things that I do. Thank you. Is that better? Yeah. Okay. The nice thing is I don't have to post answers this chapter either,
True, this is all.
because you got to check it. Okay. So try example here number 2 on your own. Graph me, solved by graphing. All right. So the blue line
It's impressive though.
looks like this. 1, 2, 3. Oops, Captain Brakes. Oh yeah, it is negative 3. I put positive 3. Oh, it doesn't look like that. Negative 3 would be down 3 right now. Or up 3 left. So then get that going on. Whammy. Okay? So then on this green one, I would subtract 6x from both sides. That gives me 2y equals negative 6x plus 4. Divide everything by 2. Gives me y equals negative 3x plus 2. Okay. Which actually ends up being, if you would notice, ends up being the exact same line. Okay. So we graph ends up being the same line, so we're already on the graph, which means that then our solution infinite solution. Okay? We can shorten that up to INF, SOS. Sure.
Totally do that on purpose.
Let them think about it.
Oh, you. Oh, just the corner. It's just a page. Wow.
Okay? Good? Love it. Try that one.
I don't know.
I like the way it's here. It's just worse because of this whole situation.
Yep.
I don't think I'd be like this if this was a situation.
Yeah, I feel like I would be more like, oh, I'm so sad.
Yeah, I so want to be done.
But I'm like, I don't see anyone. It's like a ghost town.
Yeah, it's, yeah.
Agree?
Yep,
So a solution?
no solution.
No solution.
I think it'll end at a middle of like not anything is that it'll end at
Well, okay, now I am noticing even more, like, I forgot about it, but like, now you're doing it on purpose.
I am just doing it on purpose now.
And I just like, look at the.
Try this one.
Look at other school, and like,
Blue one, done already. So positive 3 is there. 4 is up 4, right 1. And this one I'm scratched at X. Negative 5y equals negative 10x minus 15. Divide both sides by negative 5. I equals 2x plus 3. There.
it's good news.
It appears that they cross right there. So I would say that the solution would be the 0.0, 3. And if I check the solution, if I plug in 0, 4 times 0 is 0, plus 3 is 3, and 3 is equal to 3. 10 times 0 is 0. Negative 5 times 3 is 15, or negative 15, and negative 15 is equal to negative 15. Love it. Yep. Good times. You have in-personers got the homework. You have 2 homework problems to do. It's numbers 2 and 3. For some reason, I don't know why I did that. I think I was going in reverse order when I was. That's tomorrow. That's tomorrow. That's note sheet for tomorrow.
Oh,
Back page,
Oh.
week 19 worksheet, numbers 2 and 3.
Wait, Chris, what's up?
If he just said